Here I have three ratio problems, which I need to simplify down into the lowest terms. 80 centimetres to 2 metres, £4.80 to £6.40, and the most difficult one at the end, 80 centilitres to 2.5 litres. Now, the important thing with each of these is to make sure that we are working in the same units. Here I have centimetres and metres. Here I have pounds and pence. Here I have centilitres and litres. So my first thing that I will want to do is to make sure that we're working in similar units. So with this one, the larger of measurement is metres. So I'm going to turn the metres into centimetres. So this becomes 80 to 200. And the reason why are there 100 centimetres in 1 metre. Now I have a ratio that I can fairly readily simplify. Both are on the 10 times table. So my immediate first thoughts, I'll make this 8 to 20. Both are still even. And I can say this is the same as 4 to 10. Again even. And this becomes 2 to 5. If you had noticed perhaps earlier that 40 goes into 80 twice and 40 goes into 205 times, that of course would be a much more quick method of bringing it down. Here with this one, I'm going to call this 480 pence to 640 pence. And again, my first measure, I've seen immediately both have a 10 as a factor. I can bring this down to 48 to 64. Here I see they're both still even, 24 to 32. And now very readily I can see that both of these have 8 as a factor. So 8 goes into 24 3 times and 8 goes into 34 4 times. So the ratio becomes 3 to 4. The last one, 80 centilitres to 2.5 litres. I'm going to turn both of these into millilitres. There are 10 millilitres in each centilitre, so this becomes 800 and there are 1,000 millilitres in 1 litre, so 2.5 litres becomes 2,500 millilitres. Now that they're both in the same units, I can simplify. Again, I can see I have 100, so this is 8 to 25, and that's as far as it will go down because 8 is even, 25 is an odd number, with the factor is only 5. 5 doesn't go into 8, and this is as simple as it will go. So with each of these, what we must make sure at the start is that we are working in similar units for each of the parts of our ratio before we simplify them down.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.